Hi everyone, welcome back to JDCodebase, and in today's video we are starting a brand new concept in DSA, dequeue. We will understand what dequeue is, how it follows the FIFO principle, see some real life example, and where it actually used in data structure and algorithm. So let's get started. So first let's understand what exactly is a queue. A queue is a linear data structure that works on the principle of FIFO, which means first in, first out. Basically the element which goes in the first will come out first. You can imagine it like a line of people waiting at a ticket counter. The person who joined first will get the ticket first, and the last one who will have to wait. If we represent it visually from front 10, 20, 30 and 40, this is rear and this is front. And here when we add a new element, it goes at the rear end from this, and that's called the enqueue. And when we remove an element, it happens from the front end. That's called the dequeue from this side. Means if I want to add 50, then it comes after this, and if I want to remove an element from this, then this first one, this 10 remove, then 20, then 30 and so on. So now let's talk about a bit more about this FIFO concept, first in, first out. So the easiest way to remember it is think of a movie ticket line. The first person to enter the line is the first person to get the ticket. So in a queue where we perform operation enqueue and dequeue. Enqueue means adding an element at the rear, and dequeue means removing an element from the front. For example, if our queue has A, B, C, and we enqueue D, then it becomes A, B, C, D. And if we dequeue once, the first element A goes out, now the queue becomes B, C. So that's the basic idea about behind the FIFO. Now let's look at some real life example to make it even clear. The line at a ATM or ticket counter, first come, first serve, the print queue, call center system, and task scheduling in operating system, and even messages queue in asynchronous system or backend service. So as you can see, queues are not just theory, they are used everywhere in real life and in computer system too, by task scheduling and message queue and many more others. So let's quickly go over the basic operation that every queue supports. Enqueue means add an element at the to the rear. Dequeue means remove an element from the front. Peek or front gives you the first element without removing it. Is empty check if the queue is empty. Is full check if it is full. This is used when we have a fixed size queue. And we will implement all of these one by one in the upcoming videos, both using arrays and linked lists. So now the big question, where do we actually use queue in DSA? Queue plays a major role in the many algorithms, like in the breadth first search BFS, whether it is a tree or graph, queues are essential here. In CPU scheduling algorithm, operating system are queues to decide which process run next. For buffers handling, like managing data streams, and in other management system where tasks need to process in order. Also, queue are the base for more advanced structure like circular queue, priority queue, and dequeue, all of which we will cover soon. So let's quickly summarize what we learned today. Queue is a linear data structure that follow the FIFO, first in, first out. And if you remember, we in our last topic, the stack follow the LIFO, means last in, first out, and queue follow the FIFO, first in, first out. And it has operation like enqueue, dequeue, and peek. We saw real life example like line system, printer queue, and operating system tasks. And we learned that queues are used in many algorithms like BFS scheduling. So in next video we will start coding and see how to implement a queue using arrays in JavaScript. So make sure you do not miss this one. If you found this helpful, don't forget to like, share and subscribe to JDCodebase for more short and beginner friendly DSA tutorials. See you in the next one.